In today's video, we'll be continuing what seems to be an annual tradition for me and taking a look at yet another smart thermostat. And this time we'll be taking a look at Drayton Wiser. And I'll be doing this as almost a bit of a three-part series. In this first video, we'll take an in-depth look at the system and get it installed. And I'll do this almost a bit like a tutorial, giving you all the information you would need to install Drayton Wiser. Then in the next two videos, we'll take a more in-depth, nerdy look at things. In particular, we'll be taking a look at using this with OpenTherm instead of on-off control, and then we'll be taking a look at integrating this with Home Assistant. But first, if you've watched my channel for a while, you'll have possibly seen a video where almost a year ago I installed Tado. And I've been using that for about a year, and it's worked pretty well. However, since then, a couple of things have come up relating to Tado, so I want to kind of quickly go through them. If you're not interested in this and just want to see Drayton Wiser, I'll put a timestamp on your screen and a little progress bar so you can skip ahead. But since I've installed Tado, while it works really well, there's been a couple of little things that they've done that have left a bit of a bad taste in my mouth. First up, towards the start of the year, they did what they later called a marketing test, where they sent out a notification to app users saying that they would start charging to use the app. Now, they didn't end up charging and claimed it was just a marketing test, but this left a bit of a bad taste in my mouth and left me a bit concerned about the long-term usage of Tado if that's the sort of route they're even thinking about going down. Then, more recently, they've made quite a lot of changes to the API that I use to connect Home Assistant to Tado. The first change was a few months ago where they seemed to change something to do with the authentication, and it means that Home Assistant regularly loses connection to Tado and needs me to manually go in and re-authenticate. And then more recently, they sent out this delightful email basically saying that they're heavily limiting the API for people unless you pay for a Tado subscription. Now, hopefully the Home Assistant community can update the integration so it uses a lot less API calls, so it at least could still sort of be used for free, but this left quite a bad taste in my mouth and made me want to explore other options. And in particular, options like Drayton Wiser that allow Home Assistant integration over a completely local API. In fact, I've even been able to set up Drayton Wiser and integrate it with Home Assistant without even setting up a Drayton Wiser user account. Although that's all for another video, in this video we'll be setting this up as a normal user using the app. So first up, what is Drayton Wiser? Well, Drayton Wiser is a smart thermostat range that includes both conventional thermostats and smart radiator valves that you could install around your house. The range consists of several different parts, and these are kind of bundled together in different kits. The main part of any kind of Wiser setup is the hub, which you can see on the back here. You install this in a central location somewhere near your boiler, and then you hardwire it into your heating system. This then communicates with these wireless room thermostats and your radiator valves, and these can be located around your house. There are three different versions of the Wiser hub. There's a 1-channel version, a 2-channel version, and a 3-channel version. The 1-channel hub has a single switched output, and that's designed for combi boilers with a single heating zone. On the other hand, the 2-channel hub has a pair of switched outputs, one for heating and one for hot water. This is what you'd use if you have a boiler with a single heating zone and a hot water cylinder. And then finally, we have the 3-channel hub that we'll be looking at here. This has 2 switched outputs for heating, so you can use it with systems that have multiple heating zones, and it also has a 3rd switched output for hot water control for systems that have a hot water cylinder. Now for my system here, I have a combi boiler, but I have 2 heating zones. So for that sort of system, you need to use a 3-channel hub's 2 heating channel outputs, and then you just don't need to connect up the hot water channel. So just bear that in mind, because even though technically my heating system only needs 2 channels to operate, it needs to be the 3-channel hub, because on the 2-channel hub, the second channel is dedicated for hot water. It wouldn't work as a sort of second heating zone, so you need the 3-channel hub. Then, while you can go out and buy all the hubs and thermostats separately, generally you'd buy them as what they would call a kit. And these include different versions of the hub and different numbers of thermostats and radiator valves. So for my setup here, I've gone with the Thermostat Kit 3, that includes a 3-channel hub and a pair of wireless room thermostats. I've then gone out and also bought some smart radiator valves to install on a couple of radiators around the house, and we'll talk about that later. It's also worth mentioning that if you're currently shopping for a Drayton Wiser system, you'll see a mix of the original system that we have here and a new Gen 2 system. The main difference seems to be that the Gen 2 system uses a new hub and also supports a range of new sensors and devices that are released along with it. This allows it to be used more as a sort of general smart home system. So while the original system I have here is aimed purely at heating controls, the Gen 2 system is things like motion sensors, door sensors, dimmer modules, that kind of stuff. However, what seems to be really good is that the smart radiator valves and wireless thermostats seem to be interoperable between the two hubs. So this means that if I start off with this first generation hub, and then I later want to upgrade it to a generation 2 system, All I need to do is change the hub, and the rest of the parts can still be used. This is much better than Tado, where with my existing V3 Plus system, if I wanted to move to their new Tado X system, I would need to completely replace all my thermostats and all my radiator valves. So, if this new generation system came out, why did I buy the original one? Well, it simply comes down to the price. Currently, they appear to be selling the two versions in parallel, with the original generation sold as a smart heating product and the new generation sold as a separate smart home product. And currently, there are very hefty discounts on the original system. In fact, I was able to pick up this entire kit for about £150 from Screwfix, and I think at least at the time of filming, they were selling the radiator valves for about £30 each, which is a huge discount. In fact, at £150 for this Thermostat Kit 3, that's about the same price as just buying the two wireless thermostats on their own without the hub. And realistically, I don't need any of the smart home stuff that the Gen 2 system offers, so this should be absolutely fine. And as far as I can tell, the installation process and general functionality is very similar between the two systems. So in our 3-channel kit here, we get a pair of the wireless room thermostats on the top, and then under here we also get our 3-channel hub down here, like that. You also get a couple of batteries for each of the wireless thermostats in there, and then these little things here, just make sure you don't throw them out because they're quite hidden in the box, are just a couple of little tabletop stands. So if you want to install the stands on a table rather than wall mount them, you can use these little stands there. So just make sure you take them out of the box because they're quite hidden, they're quite easy to miss. These wireless thermostats will take place of my existing 2-wire thermostats, and then the hub will connect up next to my boiler. The thermostats communicate wirelessly with the hub, and then the hub controls the heating system. I've also bought a total of 4 of their smart radiator valves. So in the box you get the radiator valve itself, you get the kind of bracket and sort of screw mount nut thing that you use to mount it on top of your existing radiator valve, so you take your TRV off and fit this instead. And it also comes with this adapter here, which would be to use it with some sort of different TRV. I presume if you've got one that's like a different style, you would use that adapter there. And it also comes with a pair of AA batteries to power it. And for my setup here, I've gone with a total of 4 of these valves. With my Tado system, I went all out and installed smart radiator valves on every single radiator, I think 12 in total or so. But having lived with that for a year, I feel it's actually not necessary to do that, and in some ways can actually be detrimental. When it comes to TRVs, you have 2 main options. Either the smart radiator valves that work with systems like Drayton Wiser, or your traditional analog TRVs that you probably already have on your radiators. If we first take a look at these standard TRVs, they're actually pretty clever and often very misunderstood as to how they work. These devices are essentially thermostats. While most of them don't have any kind of temperatures printed on them, they just have these sort of little numbers printed on the side. These numbers actually does roughly relate to a room temperature. This varies between brands, but usually on most of them you'll find number 3 roughly relates to a room temperature of about 20 degrees. Then when the room gets to about that temperature, this radiator valve starts closing off flow to the radiator, so essentially what these will do is set the maximum temperature that each room can reach. Of course, what these can't do is what's called call for heat, and that means that these can't turn your heating system on or off. With a regular analog TRV, when a room starts to get a bit too cold, the valve will start to open up and allow water to enter the radiator. However, it won't be until your main thermostat calls for heat and turns the boiler on that that radiator will actually start to heat up again. So while these regular TRVs can set a maximum temperature for a room, they can't really set a minimum temperature for the room. And that's where these smart TRVs come in. Because these are connected back to the Wiser system, like a normal TRV, once the room temperature gets beyond the sort of thermostat set point, these will start to close off flow to the radiator and turn the radiator off. However, if the room then gets too cold, these smart valves can also turn your boiler on. That means that not only can the TRV set a maximum temperature for a room, it can also set the minimum temperature of the room. And the other benefit of these smart TRVs is that you can change the temperature in each room directly from the app or on a timer. However, that doesn't make these some sort of miracle device where you get a massive benefit from installing one on every single radiator. For example, if you have all your radiators set up with these smart valves and they're all configured to allow that radiator to call for heat, this can mean that if a single room gets too cold but every other room in your house is at temperature, your entire heating system will come on just to heat that single room. And this is something I noticed with my Tado system. I had a Tado smart radiator valve in my downstairs toilet, which is a tiny little room, and there was times where that room would get a little bit too cold and the smart valve in there would turn on the entire heating system just to heat that tiny little room up, and no other room needed any heat. Running a heating system in this way is very inefficient because the boiler can't dissipate all the heat it's generating into the air because only 1 or 2 radiators are allowing water through them. So if you're installing smart radiator valves, I'd recommend being very strategic about which ones you allow to trigger the boiler. For example, my house is east-west facing, so the front of the house gets sun in the morning and the back of the house gets sun in the afternoon. Therefore, I could maybe put a couple of radiator valves in rooms at the front of the house and a couple of them in rooms at the back, meaning that if the front of the house gets too cold in the evening because it's not getting any sun, those valves at the front of the house could trigger the heating. Then I'll just use these standard traditional TRVs on the vast majority of other radiators and leave them set to number 3, so about 20 degrees. That way, if any of my smart thermostats or smart radiator valves call for heat, chances are there'll be a couple of other rooms that also need heat, and the water will also be able to flow through those radiators despite them only having traditional analog TRVs. Another example where smart TRVs could be very useful is in a house where you don't have a downstairs hallway and your thermostat is in the living room. You could very easily have a situation where everyone's in the living room and therefore the room gets quite hot just from the people that are in there. This could keep your main thermostat switched off while all the other rooms upstairs in the house are starting to get too cold. Adding in a smart radiator valve in maybe 1 or 2 of these upstairs rooms would allow those rooms to trigger the boiler even if the main thermostat in the living room isn't requiring heat. So these valves are very useful, but I wouldn't necessarily recommend allowing every radiator in your house to individually call for heat. The final benefit of these smart TRVs is that they allow you to change the temperature in each room based on a schedule. And this is a useful feature, but I wouldn't recommend overusing it. With gas boilers and heat pumps, you really don't want to be overly restricting the flow through them because it will operate inefficiently. So you really shouldn't be going out and using a system like this to completely turn off radiators in rooms that you aren't using. You can maybe turn them down a tiny little bit, 1 or 2 degrees, but I wouldn't recommend turning them all completely off or setting them to really, really low temperatures. And similarly, you can always do that with a normal radiator valve. However, the time it could be useful to use a smart TRV is where you want different temperatures in different rooms, but more for comfort reasons rather than efficiency. For example, I don't like going to bed in a hot bedroom. So with a smart TRV in there, I could set it so that it maybe stops heating the bedroom in the evening while allowing other rooms in the house to stay a little bit warmer. So, when you're picking rooms to put smart TRVs in, I'd recommend thinking either, do you want that room to be able to call for heat itself, or do you have a requirement to change the temperature in that room on a schedule? And if so, then a smart radiator valve in that room could make sense. However, if all you want to do is stop a room getting above a certain temperature, these traditional analog radiator valves will do the job absolutely fine. So for my system, I'll be installing a smart radiator valve in the living room, which is at the front of the house, and the kitchen, which is at the back of the house, and then upstairs I'll install one in the main bedroom at the front of the house, and another in a bedroom at the back of the house. With this setup, I don't need to worry about the downstairs hallway having to get below a certain temperature before it fires the heating, because that's where the main thermostat is. If any of these individual sort of wider areas of the house start to get too cold, that's enough to turn the heating system on, and that'll fire up and heat the whole house up again. So now, let's take a quick run through of how we wire the system up. Drayton Wiser uses wireless thermostats, and all of these communicate back with this central hub. And it's this hub that's wired into your heating system. On the back of the hub, we have this back plate that comes off, so it goes in there and it comes off like that. And this is what you'd wire into your heating system. This is a common style of backplate that a lot of different thermostats and heating programmers in the UK use. So if you already had one of these, you could technically still use it, but different thermostats will use different terminals on these for different things. So you wouldn't want to just take your old thermostat off and put the Wiser hub on. You do potentially need to work out the wiring and potentially reconfigure it for the new system. As I mentioned, the hub is available in 3 different versions, and each of those has different wiring. So what I'll do now is we'll go through each hub, talk about how each of them is wired, and then we'll go away and install my 3-channel hub on my dual zone heating system. So first up, here we have the wiring diagram for the single channel hub, and this is what you'd use for a combi boiler with a single heating zone. This is the sort of diagram we'll take a look at here. This is out the manual. Each of these terminals relates to one of these on the hub itself. So if you put that there, you can see these are all labelled with numbers, and the numbers reflect what we're going to see on the diagram here. The actual backplate is the same across all the hubs. It's just the wiring sort of designations of each terminal will be different based on the hub you're using. As you can see, on the left-hand side, we have these line and neutral terminals, and these will need to be connected to a permanent line and neutral to power the hub. Then next to that, we have the switching terminals. We have common, off, and on. When your heating is turned off, common is connected through the switch here to the off terminal. When the Wiser system wants to turn your heating on, it will switch up here like that, and it will connect the common terminal through to the on terminal. So if we take a wider look at the diagram, we see that we have a boiler, and that is getting powered from this 3 amp fuse spur. And then out of this particular type of boiler, we have 2 switch wires. And when these wires are connected together, the boiler will turn on, and when these are disconnected from each other, the boiler will switch off. Now, of course, with your particular setup, these wires aren't going to be neatly hanging outside your boiler. They're going to be connected to your existing thermostat. So if you have an existing wireless thermostat, all these connections will be wired into the existing wireless thermostat receiver that will be installed somewhere near your boiler, and you just need to replace that with the Wiser hub. If, on the other hand, your thermostat is located somewhere else, and then that's wired back to the boiler, you need to find out where these are connected and reroute all the wires to route them into the Wiser hub. A good place to look for this would be in the back of the fuse spur, because likelihood is that they're all kind of connected through in there. You'll be able to disconnect that and wire that into your Wiser hub. So now if we're going to wire this up, we need to connect a permanent line and neutral into the line and neutral terminals on the Wiser hub. So line is going to come off that and into the line terminal. And then the neutral is going to come from, again, the fuse spur. And that is also going to go into the neutral terminal on the hub. And then we have our 2 switch wires. One of these, so we'll do switch 1, is going to need to connect to common on the Wiser hub, like that. And then the other is going to need to connect to the on terminal on the Wiser hub, like that. That way, when the Wiser hub wants to turn the heating on, it will switch across again like that. That will connect the common terminal through to the on connection, so the incoming 2 switch wires will be connected together. That will complete the circuit and turn the boiler on. And then once the rooms are up to temperature and the hub wants to turn the boiler off, it will switch back across again. You'll now see that the circuit is broken, common is not connected to on, the circuit will break, and the boiler will turn off. However, with other boilers, it might be a bit different. Instead, you might have a setup like this, where instead of having the 2 switch wires coming out the boiler, you simply have a single switched line. With these types of boilers, rather than having 2 wires that you connect together to turn the boiler on, you instead connect the switched line to a permanent line, and that will turn the boiler on. So to connect this up is very similar. Once again, we still have the neutral and line connected to the neutral line terminals on the hub. And now we need to connect the switch line from the boiler back once again into the on terminal on the Wiser hub. However, if you look at this, you can see it's not going to work right now, because there's nothing connected to the common terminal. So when the heating turns on, the on terminal will be connected through to a terminal that's completely disconnected. So what we need to do is connect a permanent line to this common terminal, so that when the heating turns on, that permanent line gets connected through to the switch line off to the boiler. So to do that, all we need to do is put a little link wire between the line terminal inside the hub into the common terminal like that, and that'll just work. The only warning here is just to make absolutely sure that you know which type of switching your boiler uses. Some boilers that use this sort of volt-free switching are also able to accept 230 volts on these switch inputs, but others can't. And on those boilers, if you feed 230 volts into one of those switch inputs, you risk frying the boiler's PCB. The best way to do this is to simply take a look at how your existing thermostat's wired and then look at the wiring diagram for that thermostat. Work out what all the wires do, label them up, and then use that information to wire up the Wiser hub. And that brings us on to the 2-channel hub. And as you can see, the wiring is now a bit different because this hub can now control both heating and hot water. Like before, we have line and neutral terminals to power the hub, and then we have 2 sets of on and 2 sets of off terminals. 1 pair for the heating and 1 for the hot water. So on this hub here, terminal 3 represents the hot water being switched on, and terminal 4 represents the heating being switched on. So in this current state here, they're both switched off. If the hot water was switched on, then it would switch over here like that, and that would connect the line through here to the hot water on switch terminal. And then if the heating was also turned on, this would switch across here, and that would connect our permanent line to the switch on terminal of the heating. Now you'll notice here that this hub doesn't have any sort of common terminal. Instead, it will always switch a 230 volt live signal to the switched outputs. This is pretty standard for any sort of heating system where you're using a hot water cylinder, but just bear in mind that if you're planning on getting a 2 or 3 channel hub and want to use it with a single zone combi boiler, you would only be able to use that if your boiler uses a 230 volt switch line input like this one here, and not if it uses volt-free switching. Well, you could use it with volt-free switching if you mess about installing an external relay and stuff like that, but we're not going to get into that here. Now, of course, you normally wouldn't buy the multi-channel hub if you've just got a single zone combi boiler, but I suppose there could be a situation where maybe the 2 or 3 channel hub is on a really good price, so you pick it up and just plan to use it with a combi, or maybe you moved house from a place that had a hot water cylinder to a place that doesn't, and you took your Wiser system with you. You can use it with a combi, but just bear that in mind. You don't have dry contacts on the 2 or 3 channel hub. So when it comes to connecting this up, if you have a heating system that has a hot water cylinder, somewhere you'll have something known as a wiring centre. And this is just a big junction box that all your heating system's components connect back to. Now, I'm not going to go into all the details of how different heating systems can be wired. You've got S-plan, Y-plan, gravity fed and so on. If you want to know more about that, check out John Ward's videos on YouTube, who goes into a lot of detail about all the different ways that heating systems can be wired. But the key thing to remember is that your existing thermostat and programmer will connect into your wiring centre. And between your programmer and your wiring centre, you'll have these 4 wires connected. You have a permanent line in neutral that we use to power the programmer, a switch line to turn on the heating, and a switch line to turn on the hot water. So to connect this up to the Wiser hub is pretty simple. You just need to identify these wires in your existing programmer thermostat, work out what they are, and connect them into the hub. So we're going to connect the neutral from there up into the neutral terminal on the Wiser hub. Do the exact same for the permanent line, again into the line terminal on the Wiser hub. And now we have our switch line for the hot water, so that's going to come up along and that's going to connect into the hot water on terminal, which we can see here is terminal 3. And then we're now going to connect this heating switch line into the heating terminal, so that's terminal 4. So that's heating in like that. And once again, that'll just work. Now at this point, the one disclaimer I would give is with heating systems, never trust the colour of a wire. Always trust exactly what it's doing. Work out what it's being used for. Don't blindly trust the colours. There's not really standards for it. So for example, here I've used grey for hot water, black for central heating. Yours could be completely the opposite way around. You might have a wire that's got the brown is your hot water and blue central heating. It could be all different kind of colours. So ignore any kind of just colouring of the wires. Don't copy any kind of wiring diagram purely based on colour. You need to identify the function of a wire and use that instead. Now with this sort of setup, the only other thing to bear in mind is that if you're replacing an existing heating programmer, so like a thing that just lets you set the time on your heating and hot water but doesn't have a built-in thermostat, you might also have a wired room thermostat somewhere else in your house. And this room thermostat will probably be connected somehow between the central heating on signal and the signal wires inside the wiring centre that let you turn the heating on. So I've added that into the diagram here. Now this room thermostat will probably be connected somewhere inside your wiring centre, but essentially what it's doing is sitting in between your central heating on system from your Wiser hub and the wiring inside the wiring centre that actually turns the heating on. Now as you can see, if we do that, the room thermostat is bridging it through. It would all work absolutely fine in this sort of situation. But then if the temperature that that room thermostat sensed reaches above its set point, that thermostat would be able to open up and break the circuit and turn the heating off, even if the Wiser hub is still calling for heat. Therefore, if you do already have an existing wired thermostat somewhere, you'd ideally need to find where it's connected inside the wiring centre, disconnect it, and bridge it out. Alternatively, you could just kind of leave this thermostat always set to its maximum temperature and hope no one ever touches it, or if you just want a quick approach to bridge it out, take the front off the thermostat, link the 2 wires together inside it, put the lid back on, and it'll kind of just be completely linked out, work normally, and you've just got a thermostat on the wall that doesn't do anything. Now, I know I said I wasn't going to go into too much detail about what happens inside this wiring centre, but I'm going to try and give a very quick explanation about roughly how this works, just so you know what you're looking at here. This diagram we have here represents what's known as an S-plan system. So what you have here is you have your boiler over here, and that's connected into the wiring centre, and then you have these 2 separate valves, one for heating and one for hot water. And these valves are motorised. So when you give them 230 volts of power, they open up, allow water to flow, and when you take away that voltage, they're spring loaded so they automatically spring back and close themselves again when they're not being powered. And with this sort of setup, these switch lines that come from your programmer are actually what controls these valves. So when your thermostat tries to turn on, say, the heating, what it's actually doing is turning on 230 volts mains power to the heating valve. That will then allow the valve to open up, and that allows water to flow. Then, when the thermostat turns the heating off, this voltage goes away, the valve stops getting power, it springs back closed again, and stops water flowing. And then you'll also notice with these valves that they have these additional orange and grey wires. And these are connected to a little switch inside the valve that turns on when the valve has fully opened. Now, if you remember the combi boiler setup, we have some sort of switch wires on the boiler that when they're connected together, the boiler turns on. So with this setup here, these switch wires for your boiler are connected to these grey and orange switch contacts on each valve. So what this means is that when your thermostat turns on the heating or hot water, it turns on the relevant valve, the valve starts to open, and then once the valve's fully opened, the switch inside the valve will close, and it's that switch that then turns on your boiler. Now, this is not something you're going to really need to get into if you're just replacing a thermostat, but it's good to know kind of how this sort of system works and what you'll be looking at. It could also potentially be useful if you ever have a problem and want to try and diagnose it. Knowing the sort of rough way these systems operate could be really useful. For example, with a system like this, if you say found, I don't know, your boiler's permanently stuck on, it's not turning off, you could easily start going and look at your thermostat and try and work out why your thermostat's not working and it still isn't working. The problem could actually be that one of your valves is stuck open or the switch inside one of your valves has failed. So it is important to kind of understand how these systems work. It's actually quite an interesting sort of lesson in very kind of simple electromechanical control. They're quite nice actually, but yeah, that's kind of how this works. And that now finally brings us on to the 3-channel hub, and that's what we'll be installing in my setup. This hub is for heating systems that have 2 separate heating zones that can be controlled independently. So you might have one thermostat for the upstairs of your house and another for downstairs, or you might have something like I do where one of your bedrooms has its own heating zone. This hub can also control a hot water cylinder, although for my setup I have a combi boiler, so I just won't be connecting the hot water output to anything, I'll just be leaving it disconnected. And then once again, here we have the wiring. Like before, we have line and neutral to power the hub, and then we have 3 separate switch terminals. Terminal 1 is your first heating zone, Terminal 2 is for your hot water, and Terminal 3 is for your second heating zone. You'll notice that like on the 2-channel hub, we don't have a common terminal. Instead, each of these outputs is just a 230 volt switched line. You'll also notice that we no longer have any terminals that are connected when it's switched off. So you can see on the 2-channel hub, we have these off terminals that are connected when the heating's turned off. We don't have that on the 3-channel hub. We just have these on terminals. Although this isn't an issue at all, since the vast majority of heating systems will only need these types of terminals. Then, like before, we have a wiring centre. It's basically the same as before, but now we have 2 separate valves for each of our heating zones, and then still have a separate hot water valve like we had before. Then, like before, we have our switch lines connecting to the wiring centre, and these will be connected to your existing programmer or your thermostats. However, this time, because we have a second heating zone, we now have 3 switch lines. We have one for hot water, one for Zone 1's heating, and one for Zone 2's heating. So to connect this up, I'm sure you can see where we're going with this. We connect neutral into the neutral, we connect line into the line terminal, we then connect the switch line for the hot water from the hot water terminal in the wiring centre into the hot water terminal on the Wiser hub, which is terminal 2. Then for Zone 1's heating, we're going to connect the Zone 1 heating coil into terminal 1 on the Wiser hub, and then for Zone 2, we're going to connect the Zone 2 switch line on the wiring centre to terminal 3 on the Wiser hub, like that. Or if you had a system like mine that didn't have a hot water cylinder, you just simply wouldn't connect the hot water at all. You would just have your 2 heating zones connected like that, and no hot water connection at all. So that was a run through of the wiring for the switch contacts that are on the back plate that connects these terminals here. But if you look on the back of your Wiser hub, you might also see this module here, labelled T1 and T2 with 42 volts DC maximum. And this is an OpenTherm module. I've talked about OpenTherm in videos before, and I'll be doing a dedicated video on using OpenTherm with Wiser, so we won't get into too much detail on this here, but essentially OpenTherm is a much smarter way to allow your thermostat to control your boiler. With the wiring we looked at previously that uses the main backplate, all that allows the Wiser hub to do is turn your boiler on or off. And when your boiler turns on, it'll run the water through your radiators at whatever temperature is set on the front of the boiler. which isn't ideal, because if the temperature set in front of your boiler is too high, what can end up happening is if the rooms are not needing that much heat, the water can come through the radiators, get the radiators far too hot, and then you end up with a situation that the rooms heat up too much, heat beyond the temperature set point, and then by the time the thermostat realises and turns the boiler off, the room is still heating up and getting a bit too hot. And you might have noticed this yourself. If you've ever had a situation where you can really feel the rooms heating up and cooling down, that can be because your boiler's flow temperature is set too high. It's also not the most efficient way to run a boiler. Of course, the alternative is to turn the flow temperature right down. But if you turn it down too low, and then the rooms are really, really cold and you need a lot of heat to heat them up, it can end up taking a super long amount of time for those rooms to heat up because the flow temperature is set too low. OpenTherm, on the other hand, is a digital connection between the thermostat and your boiler, and it allows the thermostat to request a particular flow temperature. So if the Wiser hub senses that the rooms are really, really cold and need a lot of heat, it can tell your boiler to get really, really hot and pump out a lot of heat. Then if the rooms are almost at the set point, maybe the set point's 20 degrees and the rooms are like 19.5 degrees, the Wiser hub can tell the boiler to actually sort of drop its temperature down and maybe only put out water about 40 degrees, 35 degrees. And that can really help you maintain a really nice constant indoor temperature, and it also runs a lot more efficiently. As I mentioned, we'll be doing a dedicated video on this talking about OpenTherm, but with Wiser it gets a bit weird and vague because they officially state that the single zone 1-channel hub with a combi boiler fully supports OpenTherm. But then the 2-channel and 3-channel hubs like this also contain the OpenTherm module, although there's part of the manual that states that it's only supported on the 1-channel hub, even though this supports it. They even say in a couple of places where it's not supported even if the module's present on a 2 or 3-channel hub, but then other places selling these list the 2 and 3-channel hub as supporting OpenTherm. So I tried emailing Drayton to see if they could clarify the OpenTherm situation with these, and they weren't exactly clear. But essentially what they came back with was basically what they said was they can only guarantee operation of OpenTherm on the single channel hub with the combi boiler. They went on to say that the 2 and 3 channel hubs are OpenTherm certified, but they can't guarantee their operation with OpenTherm, which doesn't make any sense to me really. So I'm not going to be using OpenTherm right now, but I will be doing a dedicated video taking a look at OpenTherm on Wiser, and in particular going into how it kind of operates on this 3-channel hub. Now I'll go into much more detail in that video, but as a very quick summary, it does work with OpenTherm, but only on the first heating channel. The hot water channel and the second heating channel, so your second zone, will not trigger the boiler over OpenTherm. Only channel 1 can trigger the boiler when OpenTherm is being used. However, when you're using OpenTherm, the relays do still operate. So it's sort of usable for my particular dual zone setup, but the boiler will only run when the main zone is calling for heat, so it is a bit of a limitation. So if you're planning on using OpenTherm with Drayton Wiser, definitely wait for the video when I go into it in more detail, but especially if you're just going for the single channel hub and you've got a combi boiler, I would strongly recommend looking into using it with OpenTherm because it is so much nicer than just basic on-off control. So that was a look at how it all works on paper, literally. Now let's take a look at the real world setup and install this into my heating system. Now taking a look at my existing heating system, we have these 2 Tado wire thermostats, one installed down here in the downstairs hallway. This is the heating zone for the whole house except one of the bedrooms, and then that other bedroom has its own Tado thermostat, and that's the second zone just for that single bedroom. Of course these are already smart Tado thermostats. Originally we just had these Danfoss traditional thermostats installed instead. The setup and wiring is exactly the same. These were just a direct swap for these, so if you've got thermostats like this, it's still the exact same sort of setup. And then taking a look inside here, we can see the wiring. Of course, this has already been safely isolated and properly tested before I took the front off and started touching this. Do not start messing about with this until you've properly isolated the power to your heating system and tested it as well to make sure it is isolated. But what we can see here is the terminals. So what we have is we have our permanent line here and then our switch line here. So the brown is a permanent line that comes in, and then as we can see up here, a very similar sort of setup to the diagram we saw on the Wiser. The common is connected through the relay to the normally open contact. When the heating turns on, this switches across and connects common to the normally open terminal. So we have our common is a permanent live, that's a permanent 230 volt live. And then when the heating turns on, that gets connected through to normally open. So the brown and black wires essentially get connected together, and that turns the heating on for this zone. Then in here, we've also got a second sort of little grey wire here. That's a neutral. This thermostat doesn't need it because it's battery operated, so it's just in these parking terminals here. These terminals do absolutely nothing. They're literally just there to stick extra wires into. So you can basically ignore these. We just have these two wires that are our switch wires. However, of course, this thermostat is downstairs and then the other thermostat is in a completely different part of the house. So I can't just replace one of these with a Wiser hub because I don't have the switch wires for both zones at a single thermostat location. So instead, we need to find the wiring centre that these both wire back to and connect the Wiser hub into that instead. So that now brings me to the garage, which is where we find the boiler. So obviously we have the boiler on the wall here, that's all powered from this fused spur located down here. And then up here, we can see we have the wiring centre. And this connects into all the other parts. So those two white things we see over there are the two zone valves we talked about earlier. So those are the valves that you give 230 volts to and they open, and then they've got a switch in them that turns the boiler on. One of those is for zone 1, one of those is for zone 2. And then here we have the wiring centre, which is where everything is wired back to. And this is where we're going to need to wire the Wiser hub into. And now here we have the inside of the wiring centre. Now of course, needless to say, once again, make sure everything is fully, safely isolated, you've tested it, you've checked it's all dead before you start touching any of this. But here we can see the inside of the wiring centre and an absolute ton of wires. Now, your wiring centre will not be kind of as neatly is a word, but as neatly laid out as this or as labelled as this. Before I did this video, because I knew I'd have to try and explain this, I went out, bought this much nicer, newer Wago wiring centre, completely rewired everything, labelled absolutely every single wire, and then now realise why people generally don't label wires, because this took hours to label and put it all back together again. But this will now be a lot easier to explain and understand. Before I did this, what I had instead was the original wiring centre was just a back box with a blanking plate up here and a bunch of connector blocks inside it. And then that was some of the connections, but then there's additional connections made in the back of the Thermostat and in the back of the spur. There's connections all over the place. So I kind of redid it, brought all the wires back up this wiring centre and put all the connections in one place to make it much easier to understand and diagnose. So what we need to do here is really locate where those thermostats are wired back to, disconnect them, and connect the Wiser hub in its place. Now of course, because all this is labelled, we can see over here we have zone 1 stat switch line and zone 2 stat switch line, so these two black wires here. These are the black wires that we saw at the thermostat. We also mentioned that the brown wire at the thermostat is a permanent line. We can find that over here, so that these are all the permanent lines connected together. So we've got the supply, the permanent line off to power the boiler, and we have these two here, which is zone 1 stat line and zone 2 stat line. These are the permanent lines that go to the brown wires behind each thermostat. And like before I mentioned, we have the neutrals at the thermostat as well, those grey wires. We can see those down here, even though they're not being used at the thermostat, we have those neutrals here. So with this setup here, essentially all we really need to do is disconnect the switch lines from each thermostat, get them out of the way, disconnect all the other thermostat wiring as well, and connect the switch lines out of the Wiser hub into the terminals that the old thermostats used to connect into. But given I explained earlier how the valves work, I'll do a quick explanation about how this all roughly works, and it might help you if your setup's not as labelled as this, to kind of help you identify which wires are your thermostats. So up at the top here, we can see we have these two wires labelled boiler on. One here and one here. And this is what we saw before, where we have the switch wires coming out the boiler. When these two wires are connected together, this brown wire and this blue wire, when these are connected together, the boiler turns on. And we can see that one of these is connected in with the grey wires that go to each valve, and the other one is connected in with the orange wires that go to each valve. And if you remember what I said before, when the valve fully opens up, the grey wire and the orange wire get connected together by a switch inside the valve. So what this means is, say for example the zone 1 valve, when that turns on, the grey wire of the zone 1 valve connects to the orange wire of the zone 1 valve. That way the boiler on signal will get switched via the valve back up here. These two boiler on signals get connected together via the valve and it turns the boiler on. And then we can see we have the switch wire that comes from the thermostats connects to the brown wire of each valve. So when the thermostat turns on, it powers up the brown wire of each valve, and that causes the valve to open. That valve opening causes the switch to close, and that connects the boiler on signals together. So if you had a system like this and it was obviously not labelled like this, that's kind of how you need to go about identifying which wires are which. You'll probably have some wires coming back from your zone valves. Those will probably be connected to some wire to signal the boiler. You could kind of trace that back, work out what is connected to the brown wire that powers each valve, and that is probably going to be what your thermostats are. So these two wires here are our thermostats. So what we need to do is get these old thermostat wires disconnected, made safe somewhere else, and connect the Wiser hub in their place. So there we go, that's the wires out of the old thermostat's now disconnected. So we've got the two neutrals, the two permanent lines, and the two switch lines. Now, you could obviously just cut these off, get rid of them. I'm not going to do that, and I wouldn't recommend you do it either, just because there's always a chance in the future you might want to repurpose these. You might want to go back to wired thermostats, or while with the Wiser system, the wireless thermostats can only be battery powered. If you, let's say in the future, switch to a system like Nest, with Nest you can use these thermostat wires to pass a sort of DC, I think 12 volts or something, from your Nest receiver to the thermostat, so at least the thermostat doesn't need batteries. So I'd recommend leaving these wires in place just in case you ever want to use them in the future. So we just need to connect these in a connector block just to make them safe. So they're not currently connected to anything, they're not live, but they're at least kind of available for future use. So there we go, that's those old thermostat wires now sort of neatly put off the side here in a couple of connectors. So I've just put them on the same connectors as each other just to kind of keep them off the side. They're not doing anything, they're just safely out of the way. I've left the CPCs connected because there's no reason not to. The cables are still running through the building, there's still wires here mixing amongst live wires, so it makes sense to kind of keep the CPC and that cable intact. So yep, that's all done there. So now all we have is the terminals that go off each zone valve empty, ready to connect the new Wiser hub to, and then likewise we have neutral and line over here that we can also connect to the Wiser hub. So now we just get a cable from this into the Wiser hub. Now, of course what you could do is just mount the Wiser hub right next to this, bring a cable out of this on the surface into it, that would be completely fine. But this is quite high up, you can see it's right against the ceiling. And then being in the garage, I don't really want cables trailing down this wall here because it'll get bashed. So what I'm going to do is, on this wall we've actually already got this back box down here. It's blanked off right now. But in the back of this, we've actually got a spare OpenTherm cable coiled up and connected in a connector block that's not being used. But I'll be using that in the future when I convert the Wiser over to using OpenTherm, and we'll be doing a dedicated video on that. So what I'll do just now, just to mount the Wiser hub in a neater place, I'll take this off and I'll mount the Wiser hub over this, and then I'll run a 5-core flex from here up through inside the wall into this wiring centre, just so the cable's completely out of the way. We'll have the Wiser hub down here, and then it'll all connect to the wiring centre. So I'll get that cable installed, and we'll take a look at how it's all connected up. And there we go, so I've now pulled in a 5-core flex up here into the wiring centre, and that runs straight down the wall and comes out this box here, and we've got the cable here. So now let's get it stripped back, and then we can wire it all up. So there we go, that's the cable now stripped back and labelled up. So as you can see, we've now got the line and neutral, the brown and blue will just power the hub, the CPC, which we don't actually need for this, but we'll just connect that to the terminal, just keep it out of the way. And then we've got our two remaining wires here. The black wire I'm going to use as the zone 1 switch line, and the grey wire we're going to use as the zone 2 switch line, and I'll just leave them out brown because when they're switched on they are essentially line voltage wires. And then up here at the wiring centre, very similar idea. The brown and blue are the line and neutral to power the hub, so they'll go into the permanent line and neutral terminals over here. And then we have our two switch lines with the sleeve that slip down. So once again, grey is zone 2, black is zone 1. So these will then connect up to the zone valve terminals up here where the old thermostats used to connect to. So there we go, that's it all now connected. So we can see over here we've got the line and neutral to the hub connected into these terminal blocks over here for the permanent line and neutral. And the switch line for zone 1 connects to the zone 1 valve, and the switch line for zone 2 connects to the zone 2 valve in the exact same terminals that the old switch lines from the old thermostats used to connect to. And then down here for the hub, I've already installed a backplate on the back box. I've wired it in. So line and neutral connected into line and neutral terminals. The switch line for zone 1 goes into terminal 1. The switch line for zone 2 goes into terminal 3. And because we've not got any sort of hot water control here, terminal 2, which is the hot water switch line, is just disconnected. So now all we need to do is install the hub on this. So to install the hub, you just loosen the two screws on the bottom off, and the hub just literally will just plug on over like that, and you just need to tighten those two little screws up. Now, you do need to watch for situations like this where you're installing the hub above something else. This here is absolutely fine because there's enough of a gap, you can get a very small screwdriver, like the bit out of a screwdriver in there, and tighten that up. But you just need to be mindful not to install it directly against something else, or like against a shelf or something, where you wouldn't be able to get in to tighten those screws. So just make sure there's enough of a gap just to get at least some sort of tool in there to be able to tighten those. But I'll get that on the wall, and then we can get this set up. And with that, we now have the Wiser hub on the wall. Now, I'm not going to do a full setup tutorial because that would take way too long, and this video is already long enough, but I'll take a very quick look at the setup process. So first of all, what we need to do is turn power on to the heating system. That'll fire the boiler up, and the Wiser hub will also start up. And because this is the first time we're setting it up, you can see the setup LEDs come on, and it's gone on a solid green on the setup LED. So now I've already set up the Drayton Wiser app, I've created a user account and logged in, and now we can set this up. The process to create a user account is dead simple, but what's really, really nice with Drayton Wiser is that if you're a professional installer, what you can do when you open the app is rather than saying you're a homeowner and setting up a user account, you can put the app into installer mode, which lets you set the device up without linking it to any kind of user account, and the customer can then come along later and then register it with their account. This is great because it means you don't need to mess about using the customer's phone, or say you're installing it on like a new build where there isn't a customer homeowner available yet. You can still fully set up and commission and test the system without linking it to an account. We'll take a look at that in more detail in the Home Assistant video, but just because this is setting up like a normal person, I've just set up an account and logged in. And now in the app we can see it says welcome to Wiser, let's add some devices. So we press plus, we need to pick the type of hub we've got a hub R, the original one, so we pick that. And it then says to press the green setup button like that, and the LED will now flash, and then we go to next. And what's now happening is the hub is broadcasting its own Wi-Fi network I can connect my phone to, and then use that to set up the Wi-Fi on my main network. So there we go, I've now gone into my Wi-Fi settings and connected to that network it's broadcasting, so we'll press continue. That's now saying we're connected, so now next. It's now going to ask me what type of boiler I've got a gas boiler, what type of control. This is where you pick OpenTherm if you're using OpenTherm, but for this video, we'll take a look at the standard control, so we're going to pick standard, press next, and now it's going to want me to set this up to connect to my main network. And there we go, we're now connected to Wi-Fi and it's taking us into the Wiser app. Well, I say that, it failed a couple of times, I had to restart the hub and now it's working, so who knows, but we're now in. And of course, we can't really do that much right now because we've not paired any of our thermostats or radiator valves, but as a quick test, if we press the hot water on button on that, we can hear a click from this and we can see the hot water lights come on. Click that again, turns off, so we are successfully controlling the Wiser hub from the app. So what we now need to do is pair those thermostats and radiator valves with the hub, and we can get the system up and running. Okay, so now what we need to do is pair some devices. Other thing you might have noticed here is currently the hot water's turned on. That's because out of the box this does come with a kind of pre-set up hot water schedule. Obviously we're not using hot water with this, it's not connected. It turning on and off isn't really a problem, but if you want to stop that you just need to go in and kind of remove your hot water schedule, set it so the hot water never turns on, and that would be fine. But what's more important to do now is start pairing devices. So what we need to do is, well, first of all pair one of the thermostats. So to do that we're going to go to control, we're going to go to the menu up here, we're going to go to devices, and we're going to press the plus button in the top right hand corner. Then we're going to pick the device we want to pair a room thermostat, and it's going to tell me to put the batteries into the room thermostat, and that should start pairing. So we've got our room thermostat here, we've got our two batteries, so we'll just pop the covers off that I thought I'd done earlier, like that. Set the two batteries in, so that one in that way and the other one in that way. And then we'll see the thermostat will then power up. Oh, it's saying it's failed on the app, so I'll just need to retry again on the app. I think I just took too long to put the batteries in, so we'll do that there. App now says joining. And in a second, this should all pair. Cool, there we go. I had to do it a couple of times there. First time it wouldn't work, I think I just took too long to put the batteries in. But that's now paired, and now it's saying we can mount the thermostat. We'll do that in a second. Press next. And what we now need to do is pick a room that this thermostat's in. So I'll make this one the downstairs hallway, so like that. And press submit. And that will now pair that thermostat with that room. Now the next thing we need to do is pick which channel this applies to. Now if you remember with this being a 2-channel hub, or sorry, a 3-channel hub, what we have is we have 2 heating channels and 1 hot water channel. If we pick this hub R channel thing here, we can see we have options for, there you go, channel 1 heating and channel 3 heating. And if you remember from when we wired it, the first heating zone is connected to terminal 1, and the second heating zone is connected to terminal 3, with terminal 2 being the hot water. So this is where we pick which of those 2 heating zones this thermostat controls. So for my setup here, channel 1 or zone 1 is what the downstairs hallway is using, so we'll pick channel 1 heating for that. We now need to do the same with our second thermostat, so we've got that here, we'll put the batteries in the back of that, like that there and that there. That's now going to start powering up and then scanning for signal. We need to go into the app, press to add device, add room thermostat, and that'll set saying joining, so we need to wait for all that to connect up. Cool, so that's that second room thermostat, that's now paired as well, so if we press the button you can see it's now showing actual stuff rather than just a sort of connection screen. We can go next, we need to create a new room. You could add it to an existing room, but why you'd have 2 thermostats in the same room, that would make sense, so we'll create a new room. This is going to be, I think, bedroom 3 is what this thermostat's going into. That's my second heating zone, is that 1 bedroom, so we can submit that. And this time we need to pick the other heating channel because this is the second zone, so we're going to go and pick channel 3 heating because that is a heating zone for bedroom 3. Press submit, and that's now set up. We've now got our 2 different rooms with our 2 wireless thermostats in them. Okay, so now the final thing I want to do is pair one of the radiator thermostats and get that installed. So, like before on the app, we're going to go to radiator thermostat. It's going to ask me to put the batteries in, so we will get the battery compartment off. Actually, yeah, it pulls off like that. Put our 2 batteries in, Battery labelling is a bit weird. It's kind of actually embossed into the metal, so it's a bit hard to make out, but that's there. So the batteries should go in that way round. That should then turn on, and then it says to twist the cap in the plus direction until the centre LED flashes green. So we're going to do that. Flashing green. It's making weird motor noises. And in theory, that should just pair it. There we go, device joined, that's worked. Now it's telling me to install it on the radiator. So I'll put the battery compartment cover back on like that. That's done there. And then what it's now saying to do is to install it. So to do that, we're going to need to take off the existing valve. So on this, there's this little thread on the bottom. Most radiator valves are all very similar. You might need adapters for some of them. These ones are all right, so that just comes off that little screw thread on the bottom. We now need to install the adapter onto the valve. So this is just the one it comes with. It comes with that one other one we don't need here. So to do that, you take this nut, you put it so that the kind of sloped side is facing the valve. So you put that like that, take the plastic piece, put that on the inside, and then screw that onto the piece on the inside of the valve, like that. And I'd recommend doing this really nice and tightly, because what you don't want to do is when you screw it onto the radiator, the inner nut to come unscrewed or anything like that. So get that nice and tight like that. And now we can put this on the radiator. So pretty easy to do, just literally lay it over the radiator, tighten the nut on the bottom. There we go, get it so it's the right way around as well. And again, get that nice and tight, because the way this works to control it is you turn the top of the valve to adjust it. And if it's not tight enough, it will end up unscrewing. So get that nice and tight on there. That's on there. And now it's finally saying it's turn the cap in the minus directions for 2 seconds to calibrate. So do that. There we go. Didn't seem to do anything there. Weirdly, it seemed to calibrate more when I first powered it up rather than calibrating now. So I'll see what happens there. Press next. Now it's asking me to pick a room, so we're going to pick a room again. This is bedroom 4, so we'll do that. Submit. And like before, we need to pick the heating channel. This bedroom is on the same heating zone as the rest of the house, except for that one bedroom. So once again, we need to pick channel 1 heating. If on the other hand, your heating system was like dual zone, where you have an upstairs zone and a downstairs zone, you would need to pick which of your 2 zones this radiator valve is on. So that's what you need to pick here. So that means if this radiator valve wants to call for heat, it will call for heat through that single zone. So we can now press submit there. And that is now done. Okay, so just quickly jumping in here. Bit weirdness with the calibration there, because as we sort of saw there, it said on the app to turn it to minus and it would just calibrate, but it didn't. I've looked it up, and what it seems to be you need to do is to put it into calibration mode. You need to turn it to the plus first for a few seconds, and then the motor should start running. There we go. Yeah, that's the motor running now. And now it's flashing. It's this sort of multicolour thing, and now if we turn it to minus, that's now calibrated. So that seems to have done it there. Bit weird on the app there is it said to do it just to turn it to minus, and it would just do it even though it wasn't in calibration mode, so not sure if that's maybe a difference with what the app says versus how it works in real life, or maybe I took a bit too long to put it on the radiator, because it did seem to sort of try to start to calibrate before I put it on the radiator, even though the app later told you to put it on the radiator after that point. Some slight difference with the instructions there, I don't know, but if yours doesn't calibrate properly, that's how you do it. And essentially what I mean by calibration is it works out how far it needs to push the pin on your radiator valve up and down to control the radiator. So if you found that you had a valve that wasn't properly controlling the radiator was never heating up or it was never shutting off, then you'd probably want to go in and recalibrate that valve. Now the final thing I wanted to cover was when I was talking earlier about these radiator valves, how you might not want them all to be able to call for heat. So you might have a room that's got a radiator valve in it, but you don't want that valve to be able to fire the boiler. You just want to use that valve to set a maximum temperature for this radiator and maybe adjust it on a schedule. Now when you first enroll the valve and set it up, you can't do this. You have to pick which of the heating channels it uses. But once it's done, what you do is you don't go into your devices section like this. You instead go into your rooms section and pick the room that the valve is in. So in this case it's bedroom 4, so we'll pick bedroom 4. In here you get a similar section set up before where you can pick which channel it applies to. But now you have the additional option of picking none for a channel. With this radiator valve now set to none for a channel, if this room gets too cold, this valve cannot turn the boiler on. So that's an option you can do there if you want that. But for my setup here, because I've only got 4 of these valves strategically placed around the house, I do want each of these valves to be able to call for heat. And the final feature we have in here is open window detection. This is available in any room that's got a radiator valve in it. Doesn't work on a normal thermostat, you do need a radiator valve. But if you turn that on, anytime the radiator valve senses potential drop in temperature that could be indicating that a window's been left open, it'll turn off the heating in this room. This is something that Tado did offer, or does still offer, but it's only part of their Auto Assist subscription, and if you use the free version it'll notify you that a window's left open, but you have to manually go in and turn it off, whereas on Drayton Wiser they don't charge you for that. You can just switch that on, and now if this room detects a draft, if the window's been left open, it'll turn the heating off in this room, which is a really nice feature to have. So yeah, with that, we've got Drayton Wiser all set up and working. Okay, so now the final thing we need to do is deal with the thermostat wiring for the old thermostats. Now, of course, as I mentioned, you could completely get rid of this, rip it all out, but I don't like ripping out cabling that's perfectly good because it could be useful in the future. So the simplest option to do would just be to put them all neatly in a Wago in the back, just keep them out of the way, and just put a blanking plate over the front, and that would do the job fine, although you have a blanking plate on the wall that you'd have to look at. Now, unfortunately, the new Wiser thermostats are much smaller than the standard back box, so you couldn't really mount them on that. They're just kind of going to fall into the hole in the wall. But instead what I've done is this. All I've done is I've taken a blanking plate, drilled a couple of holes in it, and fastened the Wiser bracket, the mounting plate for the thermostat, onto the blanking plate. So what I can do is I can screw this over that existing back box, and then just clip the Wiser thermostat onto that, and it'll make it look a bit less like a blanking plate because there'll be something actually useful there, and it means the thermostat's then mounted. There's a little bit of filling I'll need to do here and here. That's for the old thermostat that used to be here before the Tado. It was screwed in there and it's a little bit of a gap, but that won't be too hard to fix. So I'll get that on the wall and we get the thermostat mounted. So there we go, that's the blanking plate now mounted. Now take our thermostat, put that on there, and there we go. That looks completely fine. Yeah, it's maybe not as nice as the old one, the blanking plate is a bit visible. These are just blanking plates that are cheap, so I just picked them up. I could always get a sort of flat plate metal blanking plate, that would look a lot nicer. That's what I did with my Nest, but trying to get flat plate white ones are really hard. So next I'm ordering somewhere from a place that has them, I'll maybe replace that with like a flat plate metal thermostat back box or something, but we'll see. It'll do fine for now. I just need to fill that little gap in there at some point. But yep, that's the thermostat mounted. So there you have it. That was a look at installing Drayton Wiser smart heating. And so far, I'm very impressed. It was pretty easy to set up, all the hardware seemed really nice quality, and the fact that it supports a fully local Home Assistant integration and that installer mode that lets you set it up without an app and then later pass it over to a customer is really smart, and it's exactly what I'd want in a smart thermostat, and it works exactly how I'd want it to. Of course, that's all for this video, but stay tuned for the next couple of videos where we take a look at using this with OpenTherm and take an in-depth look at the Home Assistant integration. But all I have to say now is thank you very much for watching.